Hey everyone, welcome back to Mind Maths with Amna. This is part 3 of my series on the VAR model. And in this lecture, I'm going to talk about the lower triangular Cholesky decomposition of the covariance matrix of the error term. Okay, we started off, remember, with the structural form, and we had 10 parameters to estimate. A12, A21, B1, B2, B11, B12, B21, B22, and the variance of UY and the variance of UR. So it made a total of 10 unknown parameters that we wanted to estimate. We then calculated the reduced form by taking the inverse of matrix D and multiplying it by the right hand side, and then we obtained a reduced form equation which looked like this. When we estimated the reduced form, we got an estimated reduced form version and sorry, I said virgin. That's funny. Anyhow, so with these estimates, which are now known, and by the way, there are 9 of these 1, 2, 3, 4, 5, 6, 7, 8, and basically the covariance between 9, these two. So we had 9 known parameters, and from that we had to calculate 10 unknown parameters, which led to, remember, the what was it called, the over identification problem. Yeah, and basically the problem of having like infinitely many solutions because our number of unknowns exceeds the number of equations, right? So we have to impose restrictions. Okay, so how do we decide where and when to impose these restrictions? Remember, our system starts off with the structural form that looks like this: dyt is equals to, sorry, I think we said xt, is equals to c plus axt minus 1 plus ut. Remember, this is the structural form. Then we took the inverse of matrix D and we multiplied it through inverse, sorry, D inverse axt minus 1 plus D inverse of ut. And we called this reduced form as, let's just call it like this. This is a matrix. Yeah, let's just, I don't know, this kind of looks bad, but you get it. B into UD. And when we estimated it, this was, we wanted to estimate this. And when we estimated it, we got the values over here of all of these parameters. Okay. Also remember, this is a matrix and this is a column vector. Okay, so remember, the reduced form is a bit misleading. Restrictions. Okay. Point number 1. Suppose you have a 2 by 2 system. So matrix B can look like this: B11, B12, B21, B22. Okay. And suppose matrix D looks like this: N1, A12, A21, and 1. Okay, so remember, you just imagine drawing a triangle here and a triangle there, and in this system only one restriction has to be placed. So a short run restriction is which we can place is that B12 is equals to a 0, and a recursive restriction which basically eliminates any contemporary impact of one variable on the other. This is called a recursive restriction. Okay, let's practice one more. Let's suppose you had a 3 by 3 system. So for instance, our matrix could look like B11, B12, B13, B21, B22, B23, B31, B32, B33. Now let's make the triangle. Okay, so now we can see we have three restrictions, short run restrictions that we can place. And the short run restrictions will be the B12 and B13 and B23 are all equals to 0. Okay, what about the recursive restrictions? The matrix D is also going to be 3 by 3. So 1A, 1, 2, A, 1, 3, A2, 1, 1, A2, 3, A3, 1, A3, 2, A3. Oh yeah, this is going to be a 1. Okay, again, when we make this triangle, we can see that the recursive restrictions that we need to place are going to be that A12 and A13 and A23 are equals to a 0. So mathematically, if you have an n by n matrix, then the number of restrictions is simply number of restrictions that you need to place is going to be n into n minus 1 over a 2. Okay, so that's it for this question. When we take live tutorial classes, that's when I'll solve some questions which won't have like these unknown like letters. So in the class we'll solve an equation or a question where we have actual numbers. Okay, I hope this was beneficial to you, and I'll see you in the next one. Take care.